Hey, hello there and welcome back to another Advent of Code video. So December the 10th, the first two-digit number of Advent of Code. And yeah, the government changes, but Advent of Code remains the same, so we shall carry on. So carry on as a meaning to... Oh, look at this. Last day's Oasis is here. That's nice. I hadn't seen the Advent calendar again. And what were we doing? We were going up in a glider to like a metal island. So I wonder if we are there already. Pipe maze. Okay. Oh, look at this! It's a grid puzzle. Awesome. You use the hang glider to ride the hot air from desert island all the way up to the floating metal island. This island is surprisingly cold, and there definitely aren't any thermals to glide on. So you leave your hang glider behind. Oh, okay. You wander around for a while, but you don't find any people or animals. However, you do occasionally find signposts labeled hot springs, pointing in a seemingly consistent direction. What are hot springs? The kind of geysers or... Oh no, it's this, like aguas termales in Spanish. So yeah, these are cool things. I've been to some hot springs that were amazing. Well, not as giant as this. This looks really, really cool. Look at this. Awesome. So hot springs in a metal floating island. That's cool. Okay. Some signposts label hot springs pointing in a seemingly consistent direction. Maybe you can find someone at the hot springs and ask them where the desert machine parts are made. So I'm realizing now that the shape of this Advent of Code adventure is like we are going up in these floating islands things, and it's like each island depends on something that the island above them makes. So we are skipping some places here, as you can see. So I guess that when we reach the top island, if this is the metal one or something else, then we are going to start going down and providing the things that the previous island was needing. So that's cool. Or I guess that's what's going to happen, but I don't know. Okay. So yeah, we're in this hot springs thing. The landscape here is alien. Even the flowers and trees are made of metal. Cool. And you stop to admire some. As you stop to admire some metal grass, you notice something metallic scurry away in your peripheral vision and jump into a big pipe. It didn't look like any animal you have ever seen. If you want a better look, you'll need to get ahead of it. I wonder if it was like an Italian plumber instead of an animal getting into a pipe. Scanning the area, you discover that the entire field you're standing on is densely packed with pipes. It was hard to tell at first because they are the same metallic silver color as the ground. You make a quick sketch of all the surface pipes you can see, your puzzle inputs. The pipes are arranged in a two-dimensional grid of tiles. Okay, so something like this, I guess. This is a vertical pipe connecting north and south. So this is not a Unix pipe, it seems, because on Unix they connect things the other way around. Dash is a horizontal pipe connecting east and west. L is a 90-degree bend connecting north and east. Okay. J is a 90-degree bend north and west, and I see that the creator of code refuses to use Unicode characters for this, and he sticks with ASCII, and this was surely painful for him to do. But 7 goes from south to west, yeah, and F, so ugly, goes from south to east. Dot is ground, there is no pipe in this tile, and S is the starting position of the animal. There is a pipe on this tile, but your sketch doesn't show what shape the pipe has. Okay. Based on the acoustics of the animal's scurrying, you're confident the pipe that contains the animal is one large continuous loop. For example, here is a square loop of pipe. Okay, so yeah, these are bends like this, and this is a square loop. Okay. If the animal had entered this loop in the northwest corner, the sketch would instead look like this. Okay. In the above diagram, the S tile is still a 90 degree F bend. You can tell because of how the adjacent pipes connect to it. Okay, so we're going to get the S, but underneath the S there is a pipe turning right, but we don't see. Unfortunately, there are also many pipes that aren't connected to the loop. This sketch shows the same loop as above. Okay, so it's a mess of things, but here we start, and here's the loop. In the above diagram, you can still figure out which pipes from the main loop, which pipes form the main loop. They are the ones connected to S. Pipe those pipes connect to, pipes those pipes connect to, and so on. Okay, yeah. Every pipe in the main loop connects to its two neighbors, including S, which will have exactly 2 pipes connecting to it, and which is assumed to connect back to those pipes. Here's a sketch that contains slightly more complex main loop. Okay, so in here's the S, and if we go down, then turns this way, like this. Okay. Here's the same example sketch with the extra non-main loop pipe tiles also shown. So okay, we still have sort of the same thing, but with some extra pipes. If you want to get out ahead of the animal, you should find the tile in the loop that is farthest from the starting position. Because the animal is in the pipe, it doesn't make sense to measure this by direct distance. Instead, you need to find the tile that it would take the longest number of steps along the loop to reach from the starting point, regardless of which way around the loop the animal went. Okay. In the first example with a square loop, you can count the distance each tile in the loop is from the starting point like this. Okay, yeah, 0, 1, 2, 3, 4, and going in the other direction is the same thing. Makes sense. In this example, the farthest point from the start is 4 steps away. Here's a more complex loop again. Here's the distances of each tile on that loop. Okay, so the farthest away is an 8. Find a single giant loop starting at S. How many steps along the loop does it take to get from the starting position to the point farthest from the starting position? And the puzzle input will be a giant, look at this thing, a giant maze of pipes. Okay, cool, this seems like a pretty nice puzzle. So let's look at where the S is in here. Okay, it's here, and it seems like it's connected from the top and goes to the bottom. So okay, let's jump into the code. And code. Oh, I had some things from before. Let's copy the template as usual. Let's call this thing day 10 pipe maze. And let's also copy the... Oh, I made the wrong copy. Yeah, close all of these things. Oh, they can be closed with middle click. Just learned this. This is what I wanted to copy. This is going to be day 10. And the input shall be this giant monstrosity. Goes here. Don't want to see it. And then for the sample, we have 2 samples here. But I guess I could use the... this more complex sample to work with, right? Yeah, let's use this as a sample for this problem. So in this sample output, I think the answer was 8 tiles away, and that's what we want to count, right? How many steps along the loop does it take? Okay, to get from the starting position to the point farthest from the starting position. Okay, so I am already thinking about like some like premature optimization that doesn't make sense to do. So yeah, how would be a naive solution for this? I think a naive solution would be to like look around the S starting point and see, well, which of the four directions we can go. And the first one that we find is like start to follow along the pipe in that direction and push all of those coordinates into a vector until we reach the S again, because it's a giant loop. And once we have all of those coordinates, actually we don't even need the coordinates. We can just walk along, and once we find the S again, we just count the number of steps and then divide that by 2, I think. Yeah, I think that will be fine. Like in total here, they were 4, 5, 6, 7, sorry. And then we can say 8 until we reach S again. So it's going to be 8 from the start to getting back to the S. So we can divide that by 2. And I think it's always going to be even. I'm pretty sure, because this is like one of those, you can sort of see that by using like a checkered pattern on the tiles. So each tile is going to be, you can say even or odd. Like if you add the x and y coordinates of each tile, this is 0, 0, so that is even. This is 0, 1, so this is odd, even, odd, and so on. And this is 1, 0, so it's odd, and this is even, so the even goes in diagonals and the odds are diagonals too. And every time you move like up or down or left to right are changing from even to odd. So if you're starting on an even tile, you cannot get back to it in an odd number of steps, because in order to get back to it you have to go to an even tile. If you're starting on an even tile, you have to go to an odd tile and then get to an even tile again. So to get back to an even tile, you need to make an even number of movements. And yeah, I think that sort of makes some sense. I have seen that sort of argument before. And so to get back to the same tile, you're always going to be doing an even number of moves. I'm pretty sure about that. And I think we don't even need to collect the positions that we were in. We can just count the number of steps it takes to get back to the starting position. So, okay, that will be the idea of what we want to do. So let's start by putting this in some sort of grid. I guess I'm going to use a grid of, let's say, let's map or grid. Does this call a grid? I think it used the, yeah, it's a grid of tiles. So let's call this thing a grid. And we're gonna use a vector of vectors of, well, we could have a tile type, which could be an enum. Does this help with anything? I don't know. For now, let's just use characters, and we can, I want to solve part 1 and see what part 2 will ask us to do. So I don't want to like over model this unless necessary. So this will be input lines and collect. And we are going to map each line into, well, line chars and collect, right? And you don't like these, why? Oh yeah, lines does not take an argument. It's map what I want. Okay, so that was simple enough. Then we already got the grid, and we want to walk along that grid, and I guess we also want to see where the starting position is. So what are we going to need here? I guess we are going to have like our current position, and do we have some sort of direction too? I think we do. Because imagine here we're starting, we are going to look around the S position and see what we see. Like maybe this is not the best example. The square example filled with, yeah, this square example is maybe, let's use this example actually and say that what we expect is a 4, if I remember correctly, because this example also has other things, other pipes around the S, but it needs, it's these two, the ones that we can move to. So I guess we could say, okay, starting here, we're gonna see in these 4 directions, and it's like we could be asking, can I move in this direction? Can I move to the west from here? And since this is a pipe, a horizontal pipe, it should say, okay, yes, you can move, and we will move. And well, this one won't change the direction. Yes, something like that sort of makes sense. Yeah. And then if we follow that along, we should always be able to move. So, okay. What I find a bit, I'm a bit confused of what information we need to actually move. For sure, we're going to have like an XY coordinates. So let's say let mute position. It's actually not, no, it's not this, it's the position of the S in here, of the starting position, yes. Can we replace the S with, So let's start from the start and let's say start position. How do we find this? Well, we're gonna do grid, and we want to iterate and actually enumerate this thing. It's gonna be a bit ugly, I think, but let's stick with it. Yeah, we are going to enumerate, and we want to find something. And this will give me the X, but I want like the XY position. So maybe it's, let's say, find start position, and let's pass in the grid. Sure. And let's generate this thing. So you know what? I probably want to make a type alias for this. This is gonna be our grid. Let's put this here and here. Let's take the grid. And this will return a position which I probably also want to have like type point. Well, I don't know if I'm going to have that, because if we have positions and directions, like maybe maybe that those, because the positions are going to be unsigned things and directions probably signed, so I'm not sure. So let's just return this for now. And you know what, let's write a nested for loop. So for we are going to access this grid as yx basically, so y and row in grid iter enumerate, and for x and character in row iter enumerate. Well, if the character is s, then we'll return x and y, and otherwise, well, we could say unreachable here, but we don't want to fail, like crash, if the input is invalid. So we're going to say error grid does not starting position, start position not found, and this will be a result. Yes, result of this, or string, I guess. And this shall be an OK thing. And now we have some extra references here, so that's fine. And we want to short circuit this. Okay, that's good. That's good. This is going to be the start position, which is of the correct type. That's good. Then we should have something like a start direction or something like that. Is that what we want? Do I want the direction to be an enum? Maybe I want that. The direction to be an enum like northeast, southwest, and instead of like tuple, instead of like a vector thing. If we do that, maybe it will be easy to advance, although I'm not sure. So let's sketch out how we are going to write the main loop. So we're going to say something like while, or maybe even loop, and we're going to have a exit condition here. Like we're going to say if grid at y x is the s, then we have reached the starting point again, and we're going to break. Something like this. So we are going to have a mutable xy, which we are going to start as the starting position. Okay. And what are we going to do? Like how is, and we of course are also going to have a mutable count, which we are going to start at 0, and we are going to increment in each loop. So we can say count plus 1 each time we move. And how will we move around? Well, we basically want to look at what is the next tile in the direction that we are going. So yeah, we're going to need a direction. We're going to need a direction, yes. And since we are going to be adding a direction to the position, I'm wondering if we actually want to work with signed numbers. Probably won't, yeah. So what I want to do then is yeah, probably want to use signed numbers. So let's actually do type points, bite the bullet and use 2 signed numbers for this. No need for 62-bit precision here. It's be okay, something like this. And actually, you know what? This can just return an option, an optional point, and put the error message like to it over here. Say hey, okay, or and complain about the error in here. So some points, and here say none. And now this complains because this shall be of those types. And you know what? I want to use the little trick of doing a zip, starting at 0. And what's your problem here? Oh, this will be the other way around. Row Y and character X. Great. Or no, okay, or. Okay, so we're going to have something like this, and if we have a starting position, oh, and accessing the grid right like this won't work now, but I think what we should do is probably want to have a function for doing this accessing of the grid. So at xy, we're going to have an xy point on the grid. So this will give me an optional character, and this is where we're going to do like bounce checking. So let's do grid get of y as u size. So if y is a negative number, this is going to like bit extend and become and be interpreted as an unsigned number, so it's going to be a giant number. So get will fail because it will be out of bounds, and that's nice, that's what we want. And then we can short stick with this and say get again for x as u size, and that should be it. What's your problem here? Oh, that, okay. That's a reference to a character. That's fine. We can say, let's check, is this and the reference, I guess. Okay. And we can say some check. That's fine. So now we can ask here if at, and well, we can have a mutable. Does it make sense to have numbers for this? Like, I don't know if it makes sense to have the x and y's as variables, or have like a mutable position. For now, let's keep them as variables, but we shall see. And here we're gonna pass the grid, and if this is a sum s, then break. Otherwise we will continue, but actually if we go out of bounds we probably should also fail. But we're gonna, like, that doesn't happen in the actual input, so let's not worry about that. So we did nothing, right? We're just bike shading the types and things. So we should also have a direction, and for this we need to have like a first start and look at where can we move of the 4 directions around the S. But let's think about the general case, like how are we going to move? We are going to increment the position by the current direction, I think, and then look at what's on the next position, and yeah, something. How are we going to do this? Let's say match x plus dx y plus dy. Yeah, something kind of like this. Basically, we want to advance and see what we see on the next. What's the next tile, and how does it change our direction? Basically, that's what we want to do. So yeah, maybe let's just write xy be this, right? Yeah, and sure, and then let's get let character be at xy, like this is the next character in the grid. So we are doing the same thing as here, and I think we can collapse all of things. I think I want to say, okay, it's gonna be a bunch of conditionals, which I think we can do in a match statement. Let's sketch this out. It's going to depend on what's the character, and I guess how do we enter this character, right? Like if we are moving, for instance, let's say that we already know that when we start we are moving to the right, so the direction is like to the right. Then if this thing is a horizontal pipe, we are going to keep moving to the right, basically. Yeah, it won't affect us. If we were moving to the left, that's also the case. Yeah, okay. And let's imagine then, okay, we keep moving to the right, that's fine, and we encounter this. Then this changes our direction. It becomes down. Yeah, and the only things that we could find moving to the right is a 7 or a J that will turn us up. So maybe we can write something like that. Yeah, I wonder if actually having an enum for the direction does make sense. And then these would be like another match on the direction. Yeah, maybe that would make sense. And this match would, I think, be kind of easy. Yeah, let's say that, let's sketch this out also. Like, let's say we have a direction and there is this character. So if we are moving right, or I guess we can say west. You know what? It's easier to me to just say left, right, up, down than the cardinal positions. So if we are moving right and we find this, then what do we want to do this here? We want to know what is the next direction, basically. Well, we can, here we could say, okay, direction is going to be, we're not going to do anything in this case. Like, this is going to keep our direction, I guess. Yes, that makes sense. Actually, this is like if it's right or left and we find this, it doesn't change our direction. Right, and if it's up or down, actually it is left or right. That's the usual way we pronounce these things. And it's this, we also do nothing. Please remove some of the squigglies, like all of these noisy error messages are noisy. Oh, okay, yeah, this is wrong because the syntax is this. Okay, that's cool. Oh, this should be an option of a character. Sure, that sucks. So let's do let some character, and if we don't find the character here, let's fail and say went out of the grid. Okay, so let's, yeah. And you are complaining because that's not diverge. It should diverge. I'm saying like, can I say return? Okay, but I thought that using this operator would be the same, and for some reason, yeah, the semicolon there was doing all the difference. So, okay, you're happy with that? I'm happy too. Yeah. So this sort of makes some sense so far. And if we were going, let's say, let's go like, if we were going, what is the easiest? Let's go in clockwise direction. So starting from up. If we are going up and we go into a 7, we're going to change the right direction to be left, basically. If we're going up and we go into an F, we're going to change the direction to go right. There's surely a more general way of expressing this, but I'm okay with some repetition for now. Right, and we go into a J, we are going to go up. If we're going right and we go into what is 7, we're going to go down. If we're going down and we go into a J, we're going left. And if we go into an L, we're going right. Similarly, if we're going left and we get into a thing that turns us right, what would that be? I'm a bit... yeah, an L, right? This turns us up. And if you're going left and it is an F, this turns us down. Okay, those are kind of all of the valid valid turns, I think. So anything else, I think, is going to be an invalid turn. So we can say error. Invalid turn. We can format this and say, and have a nicer error message. Invalid turn going in this direction found here we're going to print the character. Okay, and we early return with this. So we need the direction enum. So let's say let's direction be up, down, left. Do I want them ordered in some way? I don't know. Up, right, down, left. This is not a let, it's an enum. Okay, and we are going to use these names because I like so. Okay, so we need a variable for this. Let's say let direction, and we need to initialize this direction somehow, like a start direction. So we're gonna do this later. And the count, we are incrementing this. I guess the count, we should increment it here, you know, when we incremented that position. And actually this condition I think can be moved inside of this. If we were going in any direction and we find the start again, we can break out of the loop, I think. And here in the end, let's print the step count. The direction doesn't know how to print itself. Sure, let's derive debug. And we need to increment x and y depending on the direction that we're in. So let's actually do a match direction. And can you, yes, do this. I love this kind of thing. If we are going up, we are going to do y plus equal. Now actually, this is grid coordinates, so this is minus equals 1. If we're going right, we're gonna do x plus equals 1. So let's actually do a kind of symmetry here. Plus equals 1, and left is going to be x minus equals 1. Okay. Sure. Why are you complaining about count here? Oh yes, because of this to do. Fine. So yeah, we are advancing. We are then checking if we go out of bounds. Fine. And here we are changing the direction depending on the pipe that we found. Okay. Sounds good to me. The last bit that we need is to pick the starting direction. So what is the starting direction? Well, it depends on the starting position, and it's not so pretty, I think. We actually kind of need to do something like this, you know? Like if we are going, we want to try each of the directions and see something like this, yeah. So can we Yeah, we are going to do something similar to this. Which is like, how do we call this? We are sort of like turning here. It's like try to turn, and yeah, these are like the valid turns, I guess. And we have a character. We have a direction here. It's so... I'm tempted to just hard code the direction that we have for our input and test it. Like, okay, yeah, let's actually do this. For the sample input that we have, we can start going to the right. So let's just hard code this for now and leave a to-do there. So used of moved value there. Where do we move this out? What is going on here? So if we try to cargo run blah 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 blah, this is day 10 with inputs 10 sample. What's your problem? Where do we move this thing? Oh, we are matching here and it's moved when we do this. Okay, yes, sure. This thing can of course be, well, debug, copy, clone, whatever you need. You don't want this because I didn't say that you were mutable, but you are, of course. Okay. So does this work for... It printed 8, but we needed to divide by 2. So that's it. Let's say this is all the... Say let's have point or half pipe length is count divided by 2, and let's print this half a pipe length. Okay, it's 4. And does this work for our actual input? Input for day 10. Where is the S? No, we cannot go right. If we make things smaller, we can go up or down. So, okay. Let's actually check what happens if we run the input. We should get into like an invalid turn. Yes, invalid turn. Going right and found this pipe. Good, so that condition was done right. What happens if we go up and try our input? Maybe we get the answer. We got a 6909, nice answer, and let's submit it. And it is correct. Okay, so yeah, no need to... We are, of course, going to implement this, but there was no need to do that to get the actual answer for part 1 and have an idea of what part 2 needs. So great. This can probably be done in a better way, but yeah, let's try to see what part 2 is about, and then we can think about refactoring this. Okay, you quickly reach the farthest point of the loop, but the animal never emerges. Maybe it's near its nest is within the area enclosed by the loop. Ooh. Ooh. To determine whether it's even worth taking the time to search for such a nest, you should calculate how many tiles are contained within the loop. For example, so if we have this starting point here, and it goes and does this shape, okay. The above loop encloses merely 4 tiles. So it's only these 2, because all of this is out. The 2 pairs of dots in the southwest and southeast, mark I below. The middle dot tiles are not in the loop. Here's the same loop again with those regions marked. Yeah, it's not in the loop because we can sort of like fluid fill from the outside. Beautiful, okay. In fact, there doesn't even need to be a full tile path to the outside for tiles to count as outside the loop. Squeezing between pipes is also allowed. Here I is still within the loop and O is still outside the loop. Ooh, this makes fluid filling even more difficult. In both of the above examples, 4 tiles are enclosed by the loop. Here's a larger example, and look at this mess. The above sketch has many random bits of ground, some of which are in the loop and some of which are outside the loop. Okay, so this is in and these are out. It's super hard to even realize like how the loop goes with these ugly ASCII characters. In this large example, 8 tiles are enclosed by the loop. Any tile that isn't part of the main loop can count as being enclosed by the loop. Sorry, any tile that isn't part of the main loop can count as being enclosed by the loop. Here's another example with many bits of junk pipe lying around that aren't enclosed by the main loop at all. So yeah, because the actual input has many pipes and lying around that are not parts of the main loop. Here's just the tiles that are enclosed by the loop marked with I. So these things, which may include pipes, I think. So this is 1, 2, 3, 4. This is the fifth line. 1, 2, 3. Sorry, 1, 2, 3, 4, 5. So it's these. There are some pipes even here, but yeah, this is enclosed by the loop. In this last example, 10 tiles are enclosed by the loop. Figure out whether you have time to search for the nest by calculating the area within the loop. How many tiles are enclosed by the loop? Wow, okay. How the hell do we do this? It is not just a simple fluid filling algorithm, because when you squeeze these loops, it's like you have to actually know what's the area inside the loop. Like when you enclose something. So how do we even do this? So if we follow along here, So it's not possible. So imagine if we marked all the squares or all the tiles that belong to the loop. It's not possible to just mark them and then, like in a second pass, do sort of like fluid fill of regions and say, okay, is this region surrounded by pipes of this loop? Because that will be true for this, but it will also be true for these O's. So it's a bit more than that, and it's like how we enclose these things. I'm thinking of an ugly way of doing this, but it might work. So what am I thinking of? I'm thinking of like duplicating the size of the input by like adding space to everything. Say the dots, replace them with like 4 dots. So it's not just duplicating, it would be like quadruplicating the area, and then have something like introduce some space between the pipes basically. So a single horizontal pipe could be replaced by, I'm thinking of doing something like, let's go to, I don't know, the README, increase the size. And for example, if we find a horizontal pipe, change this to be like 2 horizontal pipes and 2 spaces, for example. So if you have 2 horizontal pipes in a row, you would get 2 horizontal, well, this is my ligatures doing things, but you would have still a connected horizontal pipe. But you would have some space in the middle. And without space in the middle, I'm thinking of maybe we can use that space in the middle to like do a fluid filling algorithm in the extended thing and then reduce everything, like dividing by 4 again, or some like ugly thing like that. Could that work? Because it's like, imagine if you did something like that, it would leave some space between these pipes and these pipes to like fluid fill the interior of the loop. And then you could mark, then you're going to want to reduce those things and like lose, because those shouldn't count as areas. Like we should somehow connect these and these to be the interiors of the loop, but the connection doesn't count for the area. So something like that, could that work? Maybe something like that does work. I don't know if it does work like for edge cases and things like that. But it is an idea. I mean, it is an idea. I'm not even sure if expanding that way would leave us with space in every case, but maybe it does. And if we do the fluid filling like that, that seems like a very ugly way of doing that. And also quite complex to implement and try out. So you know what I'm going to do? I think I'm going to refactor this part 1 solution and leave it like more or less clean and end the video there and think about the part 2 like off camera, and then come back and try. Like once I can think of something that makes sense, come back for another session. So yeah, because I don't feel like I can think of a solution for part 2 right now. Okay, so this is actually a working solution, but it doesn't really, it's not very pretty for, well, for that we are hard coding the app direction here. We could also start down, which would work for the sample, and I think for the input too, because the input, where was the S? It's here. We can go down. Yeah, down would work. But what I want to do is probably do this. Like extract this thing. Right? Yeah. Let's try that. Let's add all of this. The changes on the README are not unnecessary. This is a semi-working solution. Let's sketch out what I want to do for the direction. Well, I want to try out all the directions. So let's say up, right, down, left. Can even use, yeah, this is fine for now. I'm wondering, like, as usual, I'm overthinking stuff, and maybe I could have a direction be, we have done similar things to this before. Not in this year's Advent of Code, but last year, where, or maybe in this year too, I don't remember. No, I think we haven't got a grid puzzle like this. No, we did in the, which one was that? No, not this one. Scratch. Yeah, the gear ratios. But we were not moving around that much. We didn't have like current positions and directions. It's not like we were a single thing moving around. So that doesn't count. But instead of like defining direction enum like we are doing here, sometimes it's also good to have like a direction be like 2 coordinates, and have like, you know, we can start like going up and then rotating that thing. But for this, we can just enumerate these things. I think there's no harm in this. So we're going to do this. We are going to iterate this thing. We are going to try each of these and say, hey, I want to find the first one that does something. And what is that something? Well, let's say find the first direction B that we can do this sort of thing. And yeah, this sort of thing is actually like, okay, starting from the start position that we got, like, can we move to there? That's sort of what we want to do. That is what we want to do, yeah. So we're going to map to a new direction, and then yeah, let's call this thing something like try move, and we're gonna have a position and a direction. And if this is some, that's what we pick as the starting direction. Okay? Instead of starting position here, we can just say X and Y, because that is our starting position. So let's inline this thing. And try move. What is this going to be? Generate this, please. We're gonna take point, which is gonna be XY, and a direction. And this is going to return an option of something that I still don't know what it is. Direction for sure, but maybe we can like put sort of almost all the logic in there. Because we also want to filter out directions that move you, like if the starting position was in the corner of the map, we also want to filter those out. So try move should not work. We're gonna do that. Sure. Yeah, let's sketch this out. This is going to have most of this logic, but reduced a little bit. So we're gonna do something like this. Let's have two mutable things here and call the direction there. So we are going to do this. We don't have a count here, and yeah, we want to know which character is, and of course we need the grid to try to move, otherwise we don't know where we are. So we're gonna receive the grid. And here let's pass in the grid, and this we can just short circuit. Okay, we're gonna have this character, and let's say let new direction is gonna be, we're gonna match the current direction and this character, and in these cases where it doesn't change the direction, we are going to keep the same direction. Okay, otherwise we are not going to do these assignments. Okay, we are going to do something like that. Yeah, and we are not going to care. Do we care about this? The S here. Try move. I think not. all of this is a bit messy, I think. But let's blow along and see what happens. So these are basically the valid mappings of the direction. If we find something else, it means that we cannot move there. Oh, but if we find an S, if we do find an S, then we're done, and that's also an important thing that we sort of want to know. How would we communicate that? And it's like, okay, if the direction was anything, and we find the basically what we had before, right? Here we had like a break out of the loop, but if this is the case, it's like, yeah, you can move there. Let's say that we continue also in this direction. So that this try move would succeed. And in any other case, we return none. Okay. So would it make sense to return then the new direction, like you passed in a position and a direction, and try move gives you back a new position and a new direction if you could make that move. I think that makes sense. So we'll return, well, here we have X and Y, which we mutated, and it's not very pretty. This mutation, but it's not bad either. Let's return this XY. So it's going to be, I guess, a tuple of this and the new direction. Something like that. Let's make it write it for us. Well, almost there. Okay. So, are you cool with that? Direction. It's weird that intuitor. Well, okay. Give me this, and if it's sum, and is there a find map? Is this what we want? I think it is. And now, okay. Yeah, we try move, and this should be. Oh, it's not. It's not. Yeah, we should find that. No, it's not find map what we want. It is actually. It was fine to be a find. What? Why did I change that? It's fine, but this is an option of direction. I want to fail if this is not possible. So no valid direction from start position found. That's what we want to do. Now direction is a direction, and I think it should work for the sample now. So if we do a check all, the sample, but we also need to update the answers. So answers, now check all, it passes. Okay, it works for this sample. And I think I also want to add the other more complex sample, this one that should yield 8. So this is going to be actually sample A, and this is going to be the sample A output, and we're going to have another file, sample B txt, which is going to be this, and another file, sample B out, which is going to be 8. And if we now check all, we have the two samples passing. That's great because the sample B is starting on like an edge of the map. So even if we try left first, I think it shouldn't fail or anything. Like we are not accessing, yeah, we are not screwing anything up there. So that's good. And well, now that we have extracted this function, also we can use it in the main logic, of course. We can say, we can reassign, we can try move, let's say, from XY in the direction that we are going with the grid. And this should be possible, right? We are expecting this to always be possible. Yeah, so how do we write this? We are going to say if sum, and we're going to have new position and new direction, and this else. Actually, you know what? We can just do this. We know this. Actually, simply assign to x and y and the direction. Like we override these variables, and this should be okay. Or we can format this, which is kind of the same as saying let else going in this direction. Yeah, something like that. Does that make sense? XY direction, we try to move. Okay, or else, and we can have this not being formatted every time. And you don't like this because oh yes, of course, we want to early return. Oh, the character going in this direction and found this character, but we don't know which character it is. So I wonder if we want this try move to also return that, so we can also know because we need the stopping condition if the character is S. So maybe we can do that. Refactoring and reconsidering all my life choices too. So what do we want to return here? Some things we want to mutate, some things we don't want to mutate, and that's fine. And okay, sure. So we want to probably assign this, but I'm actually thinking of writing this in a if-else case. Yeah. Let's bite the bullet again and say let this again is gonna be new position, new direction, and actually we are going to receive the character here. So let's return in the try move, return all of this and the character. Let's else we're gonna do this thing. Just an error with this message and early return. Okay, you're happy with this? Oh no, we don't know about this because this is the else case. Well, it's not really important. Invalidator go in this direction from, and we can print XY, I guess. Okay, and new position, mismatch types. This is a try move. Sure, this is some thingy. And we also, what are you complaining about now? Expected. Oh, yeah, because the type of this is not what we are returning. So now it's fine. Now we can, well, we will increment the count, that still remains. The direction, we will update it as direction equals new direction. And the position, we also need to update XY equals new position. Okay, and finally, we want to break if the character. So this went out of the grid is also covered by this, because the try move will return none on this case, so that's fine. We're also going to say if the character is S, we break. Okay, so we remove this logic, and I think it should be fine. I'm really not liking well, many things here, but does this thing still pass? Yes, it does. Okay, so it's not too bad, but it is kind of a mess, right? It is kind of a mess. It's like doing so much stuff, and we only took it out. We extracted this function to like choose the initial direction. Like, is there a better way of picking the initial direction, I wonder. I'm not sure. Let's finish cleaning this up. So okay, we have this mutable thing. We actually, like the xy, we are always converting this to a tuple, so we actually don't need this to be xy. We can say mute position and have it be very similar to direction. So we have the starting position, sure, and mutable direction, sure. Then here we are going to pass the position, sure, and we are going to receive the new position, sure, and we can assign this thing. Now it's a bit better. Okay, and the character, this character thing, I wonder, oh, now it doesn't know how to do this, but we can print simply the position as a debug print. That's nice. Now the character thing, it's not really necessary. Once we know that we have tried to move here, we know that this position is valid, so it's not too bad to access the grid again here, and instead of doing this, because if we did that, I think we can, like, more simply, I like the idea a bit better of just assigning the position and direction here, doing like try move, sure, okay or else, and here doing this formatting thing, or else, and format all of this gunk, and this closes the or else call, something like this, and instead of new pos and new direction, it's just going to be assigning the position and direction, and this is shorter, and you don't like this because, yeah, the character now is on the way, so we can get rid of that. We can get rid of this, sure. And here I guess we can say, hey, if the character at this position on the grid is some s, is like fine. In that case we break. So it's a bit shorter, the main loop. And that is fine, I think. This is a bit better now. Pick the starting position is fine, we can do this. I think this is better than what the equivalent find with iterators would look like. Pretty sure. So I think this is kind of it. This is basically the starting direction. Have the input and the grid. And we have this half pipe length. Yeah, okay. This is what we print on part 1. I want to just have maybe this position and direction things. Let's call this start position and have a start direction. Oops. This is start direction, just to be symmetrical. Here we can use the start position, sure. Okay, and the main mutating loop, it's a bit clearer, I guess, that you're starting from here. Oh, this can be moved here. Sure. Starting position not found, not valid direction. So it's like all of this is now part of the parsing, let's say, or the initialization of the program, and this is the main like mutable or iterative algorithm. We try to move, and if we fail, we break. Well, it's not like we break. If this try move fail is a problem with the input, so we just fail the main function, and if we find the S, we break successfully, and that's, I think, it. Try move is could probably be a bit better. This XY, you have the new direction here. I don't like the mutable parameters thing. I think maybe I would prefer having like let new position be and here just specify, okay, it's X and X minus 1. It's maybe a bit more redundant, but it also has like less mutation, which I find maybe a bit easier to follow. Okay, and this is gonna be X minus 1 and Y. This is gonna be X plus 1 and Y. It's gonna be the new position, and we're gonna return the new position and new direction. And oh, here we are going to pass the new position in here. So we are, yeah, this is only used for this. Okay. I think this is fine. We do need the S here because this is maybe a bit ugly, but fine. Yeah. Okay. Let's check that this works, and I think I am pretty okay with this. Let's add all of these changes. We have a couple of samples to check for part 1, and okay, I will think about part 2 of how the hell can we do that fruit filling thing, or like recognizing what is inside of the main loop. But I'm already a bit toasted now. I can definitely not think about part 2 right now. I will give this a try later. Let's commit these changes. Add day 10 part 1 solution. Okay, so I will think about part 2 off camera. If you've followed along with part 1, I almost forget to make a little thumbnail for, what did I get? I meant to use the toilets. This is Advent of Code day 10. Part 1, I guess. Yeah, let's call it Pipe Madness. Yeah. Because that's kind of what I'm feeling right now. Let's show a bit of the ugly code on the side. Sure enough, we can show some of the ugliness that we did today. I mean, it's not so ugly, but it's only part one. Yeah, let's actually be honest in the thumbnail and say, okay, the AOC dates day 10, part 1, new lane. What we did on part 1 was pipe walking. So yeah, I think that is day 10, part 1, pipe walking. That's it, I think, that will be it for today. If you have been, thanks for watching, and I'm Toasted. See you later. Bye bye.